And this brings me to the first presentation of the event, which is also the keynote. I would like to welcome Johannes Stang, head of Solar Lab at TÜV Rheinland, and he will talk on the status of the quality and failure modes in a module market characterized by very high cost pressure. Johannes, the floor is yours.
Yeah, absolutely. Yeah, thank you very much for the invitation to give the presentation today. Let me start my presentation. Okay, I hope that you can see now the presentation. Yeah, thank you very much for inviting me for this very important event today and to give a speech about the status of quality and failure modes in a market characterized by very high cost pressure. My name is Johannes Stang. I'm a laboratory manager and head of solar services at TÜV Rheinland. Yeah, so I divided my speech in mainly 5 points. So I will be starting with an introduction and motivation firstly, then I will follow up with the quality aspects in PV modules. Then I will deep dive into the common failure modes in PV modules, and then giving some ideas in terms of testing and certification standards. And finally, I give a very short conclusion about this keynote speech. Who's TÜV Rheinland? So TÜV Rheinland is a global and leading TIC company, testing, inspection, certification. We have more than 40 years of experience in the PV. We do power plant inspections since 1990 and have advised in over 50 gigawatt module installations globally. We have a testing capacity of over 8,000 square meter worldwide, and this is done by 250 experts worldwide. So we're trying to be very active in the ISC/TC 82, and we led more than 20 working groups to develop and make standardization better. We are also very strong in development of new test services and standards. So if there's maybe a standard not existing, we develop our so-called TÜV Rheinland specifications, the 2 PFGs. We do that because we want to enable our customers to stand out of competition and to promote their products for end customer side. And this is done globally. So we have a worldwide orientation and focus on all markets, with the American, the Europe, African, or Asian market. And we are having offices and expert subs globally. Yeah, the motivation of my speech today, I think you all will agree with me that the performance and the lifespan of PV modules is directly dependent on the quality. And you will also most probably agree with me that also or even minor defects in material and manufacturing can lead to power loss, safety issues, or early system failures. And that is something what we have to avoid. Because only high quality modules can last for 25 years or more. And on the other side, poorly made modules might degrade fast and sure can reduce the return of investment. And I think that is the most important point we should avoid is damaging customer trusts. Yeah, that brings me directly to the quality aspects in PV modules. And from our perspective, the quality depends on material, the manufacturing, and also the qualification testing. These 3 points can be further divided in 5 points. Material, that is clear, but the manufacturing itself can also be divided in the production, the process control, also the staff, so production operators, and last but not least, the testing and certification, which gives indication about the quality. I think that is nothing new that a module consists of different materials. The structure can be different, a glass module or glass foil module with polymeric material, framed or unframed. But there are a couple of different points to be aware of to enable manufacturers to have a good PV module. And without having good material quality, you will not end up with high quality modules. I don't want to go too much in detail in this slide, but I just want to give an overview and giving also some ideas what kind of quality aspects need to be aware when you select materials. Yeah. Especially for components, we have recently seen that there were a lot of developments in the standardization. So, for example, for polymeric backsheets, there's an international standard existing, the IEC 62788-2-1, and also for the other electric components and connections, there are existing standards, which also facilitating and enabling the quality assurance. Yeah, as I said earlier, the quality depends also on production, and that there are mainly 3 points. Starting with the manufacturing quality, a quality system, ISO 9001. I think that is state of the art that manufacturers and companies having such quality system, because it gives a good opportunity to go step by step through the processes and to improve processes and to target the customer requirements. So from our experience and also expectation, it is very crucial that manufacturers doing material inspections and external supplier audits, supplier qualifications, maybe having also a master list of suppliers to make a rating of different suppliers to see what is the best material source. From our expectation or from our experience, also the local sourcing of machines, equipment, service, that is important because having very short distances that can also be led to shorter downtimes of machines and also regular maintenance, spare parts, and what else going hand in hand with local sourcing. Yeah. Supply chain management, from our perspective, is also a key for manufacturing quality. You have to make, as I said earlier, supplier audits and having a very sophisticated management of supply chain, also in terms of, for example, sustainability and worker rights. The second point is the process control. That is something what we see so often during factory inspections, that inline and end-of-line testing is important. For example, to see if the soldering quality, the tapping and stringing of cells is good before the module is entering the lamination process, to avoid very costly rework if it is possible. So if a module is laminated, there is no rework possible in terms of soldering. We feel comfortable if manufacturers having traceability of materials and process data, that you have a back tracing from serial number to each production step and raw material supply, because if you get a claim, you can also see at which manufacturing step you have to improve. What we see also essential is that you have an during production testing, that you not only prove the quality of products during a type proof and safety qualification, which is done maybe one time and then lasts for 5 years. Continuous production surveillance is important, and best would be also to make a correlation with continuous field monitoring and feedback loops. Testing is good, but the real nature exposure of modules can also get or give information how to improve modules. Last but not least, and from our experience, also the production operators, your staff in the production is very important. The education of staff, that you have a proper selection of staff to the particular or specific production steps, that you have experienced staff, that you have an expert for soldering, for cell soldering and tapping, that's an easy example, and that you have regular trainings and also an upskilling of staff to encourage your staff to further develop. The third point is testing and certification. That is clear that a man from TÜV Rheinland is now speaking about testing and certification, but indeed it is important that you have standardized processes and standards to prove the quality and the safety of products. The minimum requirement is type-approved and safety, and it is targeting the infant failures of modules. That is not in lifetime testing, but it gives good ideas if the product has the ability to have a lifetime of 25 years or longer. And what we do also in the framework of an qualification testing is in regular production surveillance. I always tell my customer or customer that it is not the police coming to the production. It is more an face-to-face and on the same level discussion about production qualities to bring manufacturers in a position to improve and giving ideas and also maybe points to be improved. That is a very good chance to the manufacturers to improve. As I said, the type-approved and safety, that is not a lifetime testing, but there are a lot of different quality monitoring systems available. I want to briefly introduce our program from TÜV Rheinland for consistent quality monitoring. That is quality control PV. That has been developed by TÜV Rheinland and is written in a TÜV Rheinland specification, the 2PFG 2715. It consists of an extended stress testing according to the very internationally recognized extended stress test standard. And we added also a regular surveillance monitoring, which is done monthly and during production. The slide will show you the approach. We have the extended stress testing on the left-hand side according to the technical specification 63209-1. And on the right-hand side, you can see the monthly quality testing. That means that is something what I have shown on the slide where I said that during production testing and also monthly and also climatic chamber tests during production is essential, and that is our approach for it, that we select modules at a manufacturer line on a monthly basis and put them into testing to prove that there's a continuous quality. And also the during production, that is mostly already established for manufacturers having a high level of production qualities, that they do wet leakage current test for insulation, reverse current test, also encapsulation test that is foreseen and partly also required by test standards like the UL standards, but that is also part of our extended quality assurance program. Yeah, so now we're entering the failure modes and I think that is the keynote of my presentation also, and it will support the idea. I just wanted to draw the attention to the point that we had increased failure rates in recent projects. Recent projects are projects during the last year, and that we found mostly no project. Project means a qualification project or a test project without having observations, meaning maybe visual defects or also test failures in common qualification tests. We have seen that many failures occurred during initial measurements. The pie diagram on the right-hand side show it mostly wet leakage current test. That means severe issues of modules with insulation strengths. We have seen also bad manufacturing qualities during the visual inspection. And we have seen also many tests related to environmental stress tests, like the PID test, thermocycling tests, but also points which impairs the mechanical integrity of modules. We have many failures during the mechanical load test, and what is very severe for safety reasons is failures affecting the electrical coordination. That means that the module, for example, a module with class 2 is not safe anymore, and that concerns us. I don't want to say that all products are having not a good quality, but we see, unfortunately, an increased rate. Yeah, so please get me right. I don't want to blame every manufacturer, but I just want to give an idea that we have to be aware of module qualities. To understand failure missions and root cause, I put in this table to give common failure modes and give also correlated failure mechanism and root cause, because knowing the failure mechanism and root cause, you can avoid such failures. I think I can speak a day or longer about such correlations, and therefore I just want to give the information and giving the table to you that you be aware of such failures, and maybe giving examples what we have faced in recent programs. Mostly we see cracks in solar cells. We see moisture ingress and delaminations in modules. We see also discolorations of polymeric materials caused by UV radiations. And what's very common at the moment is power degradations caused by PID, LID, LETD, UV induced degradations, and so on. And that concerns us that on the technology side of solar cells, these points should be aware and also mitigated during cell production processes. Okay, now I will give you some examples. So we have seen the browning, and I'm not talking about polymeric materials 10 years ago. So that is what we have seen in recent projects. We see delaminations and moisture ingress. Here you can see that we have still modules, especially for niche markets in our laboratory, having smaller cells. We see glass breakages during mechanical load testing. We've seen that module designs have not been properly developed, for example, for P1 or P2 trackers, having an asymmetrical load application and leading to an dismantling or a bending of frame pieces. That is very interesting. What we have seen that type labels are cracking because of UV exposure. We see bubbles because of lamination issues, and also being very close to the module edge in the creepage distance, which guarantees electrical safety, for example. We see delaminations also on BIPV products. I hope that you can see that that is a colored front side glass, and I hope that you can see its lamination underneath. We see still hotspot defects, burns and delaminations caused by local overheating, leading to a melding of polymeric materials. And we see also bubbles in the creepage distances, which are very severe in terms of the electrical safety. But we see also not material-related failures. We see also observations for UV ultraviolet induced degradations, mostly seen for N-type bifacial solar cells, for example, silicon heterojunction cells, and also for TOPCon cells. I put in the slide on the right-hand side some 3 electroluminescence pictures. You see on the top a measurement in the initial state, and the second from the top, or the middle one, after 60 kilowatt hours per square meter of UV irradiation. And you can see that already in the IV curve, that after 60 kilowatt hours per square meter, you have seen a power loss of roughly 4%, and that there is no continuous having an higher exposure of, for example, 120 kilowatt hours or 120 kilowatt hours per square meter, bringing us to the conclusion that such degradations might be already completed after 60 kilowatt hours, and that can be over 5%. In this example, it is 4%, and that is very critical in terms of energy production and energy yield. Yeah, as I said, we have also a lot of different TÜV Rheinland specifications developed to address mostly all failure modes we have seen in laboratory testing or in field installation of modules, and with the goal or with the aim to avoid them or to detect them as early as possible. That is just in slide listing the most relevant standards. We have, as I said, a lot of standards more. If you are facing issues, you can get in contact with us. I'm pretty sure that we have standards and solutions available to address and to support you with all testings in the PV industry. The conclusion, finally, I hope that I have, or that I could show that the module quality depends on the material integrity and manufacturing precision, and that testing can support and help with detecting of failures. And I think it should also be sure that failure modes can be mitigated through proper material selection and proper process control. Testing helps to detect failures as early as possible and to optimize the PV module design, and adhering to international standards, it can help that PV modules have the chance to be reliable, durable, efficient for more than for 25 years or more. I don't want to say that quality only is when you're adhering or when you're adhering to standards, but standards and testing certification can build trust in the product, in the solar energy. And I think that is very important for end customers, that they see that products are safe and high quality. And that brings me to the end of my presentation. I have to say thank you very much for your attention. I'm very open to answer questions you have maybe added to the chat channel.
Great. Thanks a lot, Johannes. I think this is a very nice overview and nice keynote. So I have one question. Maybe I will ask our audience to put their questions in the chat window. But you showed there are 5 basic causes like material, production, process control, operators, or manpower, testing, and standards. So which one of you attribute to the most of the common failures you see in the field? If you have to rank.
Oh, that is a very tough question. So from our perspective, I mean, it is mostly related to materials and manufacturing. What I have shown here in the material quality slide is that a proper selection of module design and material, that is very important. So if I would need to rank it, if you have not a proper design of your modules, that will definitely lead to testing failures, what we have seen in our laboratory. But I see also that the production quality is of essential. I would say material first and then production quality second.
Okay. Thanks a lot. And then if there are any further questions in the chat window, please try to answer while you enjoy the conference.
Absolutely. Thank you very much.
Thank you.